Welcome to All Things Policy, a daily podcast by the Takshashila Institution. We are a bunch of policy nerds based in Bengaluru, and we like bringing fresh perspectives to Indian affairs and Indian perspectives to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hi, I'm Sarthak and I welcome you to All Things Policy. Elections look messy. In different countries, the election rules are different, the issues vary, the voters are of course different, and so are the candidates. On the day of the results, the cluttered mosaic of tiles on a TV screen kind of captures how messy elections are. But underneath all this, do elections follow a simple and universal pattern? In this episode, we will discuss about these patterns. I have with me Dr. Aanjaneya Kumar. He's a complexity postdoctoral fellow at the Santa Fe Institute. He and his co-authors, Ritam Pal and MS Santhanam, have a fascinating paper that identifies simple universal patterns in elections. What is even more interesting is that they draw inspiration from statistical physics and complex systems to gain a deeper understanding of elections. Hi, Aanjaneya. Welcome to All Things Policy.
Hi, Sarthak. Thank you for having me here. And I look forward to this discussion on statistical physics, complex systems, and elections.
Yeah, that's pretty fascinating. All three things in one sentence. In fact, my first question is that what made you look at elections through the lens of complex systems and statistical physics? And in fact, why did you think that it makes for a case for complex system?
Yeah, I think that's a very important question to start with. I think our primary motivation for looking at elections was that the year 2024 was very special in a way that 64 different countries had their general elections in 2024, which meant that, over 2 billion people across the world participated in this, large scale human experiment of collective decision making where they come together and cast their vote based on, what their opinions are and collectively decide who their representatives should be. And if you think about elections, I think elections are great examples of complex systems. So how do we think about defining complex systems? Finding a concrete, precise definition is very hard. But we can say, what are some features, general features of complex systems? For example, they consist of many different units which interact with each other. And we can't understand the whole system by just looking at parts of it. And if you really think about it, elections are a great example of complex systems, where you have a bunch of different people influencing each other, talking to each other. And you can't understand, the outcome of an election just by looking at a part of it. I think you need to look at the system on the whole, look at all the interactions together. So whether you consider the different units to be the different people in the election, or if you consider the different units to be the different constituencies in this election or different polling booths. So you can think about this problem in various scales. But one thing is for sure that elections are like a prime example of complex systems. And this past year, 2024, where so many different countries had their elections, I think that was a great motivation to start taking this analogy seriously. And that is what we did in this paper.
So, Anjana, if I have to maybe draw a parallel, right? Any other relatable example of complex system? Maybe we can say traffic is a complex system where you have, again, multiple cars, multiple vehicles. Again, they're all following maybe simple rules, but then you have different kinds of emergent phenomena. For instance, you will have a traffic jam. Maybe you don't have an accident, or maybe there is no lane closure. Despite that, you might have jams.
Yes.
Right. So there are different rules of behavior between entities, but then something else completely emerges. There is no central control.
Yeah. And you can't understand traffic jams just by looking at a single car. It is an emergent phenomena, which is a feature of all the cars in that road together.
Yeah. And there are so many other examples, I guess, how the birds flock, how their shapes keep on changing, the different patterns that emerge, right? So these are all examples of complex system, I would say.
Yes.
So the inherent feature is something new emerges. And that is also something you analyze in elections, right? So when we think of elections, generally any election, right, there are multiple candidates, there are multiple political parties, there are different issues out there. And again, the different candidates and they will have their own poll promises. The political parties will have their own manifesto points. So it always seems that there are many factors at play. However, the way you have analyzed election, you identify some clear patterns. How can we make sense of this contradiction? Right, multiple players, multiple parties, multiple issues, maybe, but a pattern emerges.
I think that's a very deep question to a large extent, and I'm still trying to gain like a better understanding of this. But let me try to offer you like how I think about this problem. In physics, there is this notion of universality, which is that a bunch of different systems, which are very distinct when you look at them, in all their detail, seem to behave in a very similar fashion under certain circumstances. For example, in physics, there is a notion of a phase transition, and a bunch of different systems sort of behave similarly, close to a phase transition. And those systems are said to be in a universality class. But we don't have to go into those details. But I think just this idea from physics that, seemingly distinct systems can behave in a very similar way is the notion of universality. And that is what we were sort of borrowing from the literature of statistical physics. And universality is also, a very common feature of complex systems where you have a bunch of different complex systems which have, different kinds of interactions, and, they are situated in very different settings. But you'll be surprised at how many times you're able to find certain patterns of similarity
Yeah.
Between those systems. And I feel like, so when we were looking at election data across the world, data from elections over a century, from I think 34 different countries, we started looking at measures of competition. And I think the decision to look at competition was also that, it is a very natural thing to define in elections, because the question of, whether this election was competitive or whether it was a landslide election is, I think, a question that we ask very regularly.
Yeah.
But also, there were other kinds of motivation to, start looking at competition, because people in complex systems and statistical physics have looked at, really fun problems of looking at how competitive basketball games are. And they found like amazing patterns of similarity between, like the fluctuations of the scores between different teams, the
Yeah.
differences between the scores of different teams, and how certain things are universal in basketball scoring. And if you think about, like two candidates and like people voting for one or the other, and if you think about this process dynamically, you can also imagine this as, like every vote is like, a basket scored for a team.
Yeah.
And so the difference between the votes of the winner and the runner-up, we just felt like it is, of course, an important quantity to study, but borrowing from these other works on how margin of victory can sometimes be universal, I think we were very interested in diving deep into like margin of victories in elections. And I think, as we will discuss, we didn't find any universal patterns just in the margin of victory, because that information wasn't complete. We also needed the information of what was the turnout of the elections.
Yeah. In fact, you focus on two variables, right? The victory margins and turnout in each election.
Yes, and it is a combination of those variables which sort of led to this pattern, which seemed to be the same. So we call this a universality or a statistical regularity. So that pattern seemed to be repeated, in different elections in different countries and in like different parts of the last century, which was surprising, because you would imagine that different elections have very different stories behind them. Of course, the candidates are often different, and they have a very different narrative. So there are very different narratives behind each election, and yet there seemed to be this robust pattern which was emerging from all of these elections, except a few which I think we will also talk about.
Yeah, we'll discuss about that. Yeah, in fact, you focus on two variables, right? Victory margins and turnout. And again, I think victory margin to a large extent tells us about the degree of competition, right? If the margin is large, it implies that there's a huge consensus for one particular candidate. The other candidates, at least the second candidate or the third candidate, they didn't have that much they don't have that much legitimacy, and they don't have that much support. Also, you look at the turnout in each elections. Now, why did you pick up these two variables? Why do you think that these were significant in understanding election competition? Now, again, the way I'm approaching is there could be so many other variables. Any specific reason why you thought that these two things will give you something apart from the basketball analogy?
So I think let me answer this question using the way you phrased the question.
Yeah.
So margin of victory is definitely, like you said, a measure of competition, because if the margin is very, very large, then it gives you a sense of, okay, maybe there's only one strong candidate, and if the margin is small, then you feel like, okay, this was a very competitive election. But when we talk about large and small, the question is large or small compared to what? So, for example, if I tell you that, there are these two constituencies, in one of the constituencies, the margin of victory is 100, and in the other, it is 1,000. That information isn't sufficient for us to say which election was a landslide and which election was, more competitive. We also need to know how many people voted in those two constituencies. So, for example, when the margin was 100, and if the turnout is 150, I would say that is a rather remarkable margin of victory. Whereas in the case where the margin of victory was 1,000, but the turnout was 100,000, hypothetically, that would be a much smaller margin. And you would say that is a more competitive election, more closely fought election.
Yeah.
So, like, putting these insights together, margin doesn't really, make sense without the knowledge of turnout.
Yeah.
So I think this is what sort of motivated us to look at these two quantities together, and especially look at the ratio of margin over turnout, which is a number which falls between 0 and 1. If margin divided by turnout is equal to 1, that means that everyone voted for this one candidate. And if the margin is 0, then you would say that, okay, the top two candidates roughly got the same votes.
Yeah.
So this quantity, sort of seemed like the simplest way in which we can quantify the competitiveness of the elections. And that is why, we chose this as one of the first things we wanted to look at.
Yeah. And you arrive at two fascinating trends, right? One is the turnout distributions. Though they look very different across countries, the victory margin is primarily driven by the voter turnout. And also the margin to turnout ratio, it remains more or less constant across countries. Am I correct in my interpretation?
Yes, you're correct. And let me just clarify what I think you mean by margin over turnout remaining constant over countries. And that is that, so a country is made up of many electoral units, and for each electoral unit we can define what the margin over turnout is. And we can put all of this data together for all the electoral units and make a histogram or a probability distribution of this quantity, which is the margin over turnout. And what we're saying is that for different countries and for different elections, this distribution is the same.
Yeah.
Yeah. So the margin over turnout is not strictly a constant, because it takes very different values. So it has like a spread of values, which we call the distribution. And that spread seems to be the same across countries and across elections, across decades, which was the second result that very nicely summarized.
Yeah. And again, the size of the electoral units don't vary, right? Even if you look at things at a smaller scale, at the polling booth level, or at the counties level, polling booth level in India and Canada, and counties in the US, or if you look at the constituency level or at the congressional district level, this remains more or less same.
Absolutely. And that was another, very surprising feature of these elections, which was that irrespective of what scale we were looking at, suppose we want to look at the finest scale available, which is, for example, in India, it would be the polling booth level data.
Yeah.
And if we compute like the margin over turnout with polling booth level data, or if we slightly coarse grain and look at the constituency level data, I think in both these cases this result of universality, which was that the distribution of margin over turnout remaining the same, was robust. And it did not seem to be depending on the details of the election, like the scale at which we were looking, or which election we were looking at specifically. Was it the 2014 or any other election?
Now, I have one counter question,
Yes.
right? So the trends that you observe, again, is there a possibility that it is just a coincidence? How is it maybe different from an emergent pattern that is arising out of a complex system? How can we, with 100% confidence, say that it is a complex system? That's why we are having this emergent phenomenon.
Yeah, I think that is like a question that keeps complex system scientists up at night, like very often, in the sense that you're absolutely right. So in the paper, we also come up with like a simple mechanistic model which tries to explain, how such robustness can arise.
Hmm.
And maybe let me, address that model part in the second half of my answer. But like, I think the first half of the answer is that it is very hard to be sure that it is a universal pattern and it is not just a coincidence. I feel like for this case specifically, for elections, let's say that it is a coincidence. And it is going to be very easy for us to, check this hypothesis whether it is really a robust pattern or if it is a coincidence, because elections are going to keep happening. And so this election data on margin over turnout is going to keep getting available to us. And the narratives and stories behind elections are going to keep changing.
Hmm.
But this analysis that we've done can sort of be made into something that you do every election in every country, and this could be like a way to check whether this is really robust, or if it was just an artifact of the last 100 years where everything was behaving the same way. So I already feel like there is enough evidence to say that okay, there is something more than just a coincidence. But the question is, okay, what is that something more? And to think about what, like, whether this is a universality or if it was like something else. Like what we decided to do, because we're also like physicists who like to solve math problems. We decided to come up with like a simple math model which captures like the basic features of elections, which is like, okay, you have many electoral units. In each unit you have some number of candidates and some people that turn out to vote, and there are some probabilistic rules through which people are voting, and that probabilistic rules are supposed to capture all the messiness and noisiness of real world elections. But this very simple model, I think, did a very good job at capturing this universality.
Okay.
So that suggests that I think there is something more. Like, so you can't necessarily claim that, oh, this election. So a lot of people have very complicated models for elections in different years, and those models are often not the same. And even the simple model is able to reproduce the pattern that we see in election data across the years. I think that suggests that there is something deeper, which is sort of context independent, that is emerging. And we do see signatures of this in regular like statistics. So if people are like familiar with some statistics, they would have heard this term called the central limit theorem, where if you have,
really better if you could explain it.
yeah. So suppose like you have data from like you have a lot of data which you can say that they're sort of independent from each other. So like a classic example is, if you look at a country and if you look at the heights of, let's say, all the men in a country, and like, so the height of one person is like a data point, but you have many men like in a country, so you can like have now a distribution or a spread of like what the heights are. And under some very simple transformations of this spread, like you can see that this distribution always goes to a Gaussian distribution with like a mean at 0 and variance of 1.
Correct.
And the transformations are simple scaling transformations, which I don't think are necessary for this discussion. But the general idea that when you have a bunch of data, and that data can be coming from very different types of sources. So like one data set could be just heights of men, the other data set could be the amount of rainfall that we've received in a particular place over a bunch of time. And these data sets, when you put them together, when you don't put them together, but when you plot the same thing in both of them, they resemble a Gaussian distribution with a given mean and a given standard deviation.
Yeah, that is quite interesting. In fact, I have something associated. It might sound like a stupid question, but is it applicable to all elections? Not necessarily the elections for maybe public positions, maybe elections which are maybe at the resident welfare association level.
So I think there are two parts to this question. So one, what is the scale of elections? Because to be able to make robust histograms,
Yeah.
you do need, or to be able to find these robust probability distributions from data, you need a certain amount of data. And like, for example, in those smaller scale elections that you mentioned, which could just be like for a society, there are often just like two candidates, and that is just one, and people are voting for one candidate or the other, and that is one data point.
Yeah.
And the nice thing about the large scale general elections is that for each polling booth, you have a data point. Right? And so you are able to make these nice probability distributions. Whereas for the elections that you mentioned, you might not be able to do it. But the other part of this question is like, okay, so there are these smaller scale elections, but there are also large scale elections. For example, we just had the New York City mayor election, which I think got a lot of limelight. And there you had, it wasn't the first past the post where, okay, one person votes for one person type of system. It was rather a ranked choice ballot. And there are ways in which the analysis that we've done can be adapted to those settings as well. For example, like you can define margin of victory. You have to think a little carefully about it, but you can define the margin of victory even in those ranked choice voting systems. And one can see like what the results turn out to be. Like I don't have a good intuition for whether the universality should hold or not. And I guess that will also depend on how we define the margin of victory.
Okay. One associated question, since you have been able to figure out some trends in elections, how can these trends be relevant for, let's say, policymakers or those who are managing elections, maybe the election commissions?
Yeah. So I think there is one direct way in which these can be useful, or like this information can be useful for, let's say, the election commission to have. And let me tell you like some analysis that we were doing. So I am talking about like statistical regularity, and okay, you plot a distribution and it looks the same in different countries and different elections. But that wasn't the case in all of the elections. And specifically, there were like two elections where we did the same analysis and the results were way off. They were like way more different. So they were very different from what the model would predict, or what the patterns that other countries were sort of showing. And that sort of motivated Ritam, me, and Professor Santanam, like the election team, to dive deeper into those elections and see what was going on there. And what we found out was that in both the elections where there were these very significant deviations from model predictions, there was clear indication of electoral fraud. Like there were many scholarly articles, there were many media reports that something had been, so there were fraudulent aspects of those elections, which led us to believe that maybe this statistical regularity that we are seeing is not just, like a cute statistical theorem or a mathematical artifact. Rather, it could also be a very useful tool to flag abnormalities in an election. And those abnormalities, there is no reason for us to believe that those abnormalities always signify electoral fraud. But they definitely tell us that, okay, something very different is happening that hasn't happened before.
So basically, it can be a starting point, and again, for the election commissions to again look for what are things which are possibly going wrong.
For sure. So it could be like a starting point to at least flag certain outliers. And I think already, political scientists, economists, statisticians have been working on detecting electoral fraud for a really long time. So we definitely aren't the first people to be coming up with like a way to flag fraudulent elections. But I think a lot of times, these things end up being like an evolutionary arms race. So, for example, like there was a very nice law called Benford's law, which says that if you have like a naturally occurring data set, like whatever we mean by naturally occurring data set, I think all they meant was data sets which aren't artificially tampered with.
Hmm.
The first digits of the number, the leading digits of all the data points, follow a certain trend, which is that like the number one is most likely to be so it's the most frequently present number, and then followed by number two, which is the second most frequent leading digit, and so on. And once this was realized, I think this was used to find a lot of tax fraud in the US.
Okay. Oh, wow. That's interesting.
But once people who want to do tax fraud realize this, I think it became very easy for people to like tamper their data in a way that they just follow Benford's law and still are able to get what they want out of it. So Benford's law is also something that has been used to flag election data, and there are many, many other measures. And I feel like the more measures we have, the tighter control we can have over the integrity of the elections, and the better we can safeguard them. Because you may try to tamper with data in a certain way which complies with one measure, but complying with more and more measures becomes more and more difficult.
Yeah. So you try to understand elections, identify some trend, but are there other democratic processes that show similar universal patterns? Are you exploring any of those things? For instance, do protests have some similar patterns world over, or something else?
Yeah, I think like that's a very interesting question, and like protests are a very important part of, again, safeguarding democracy. But I feel like the questions will have to be very different. And like if I'm just sort of brainstorming with you over here, one can look at protest size distributions. Like, okay, for a given movement, like you have multiple protests, and what are the distribution of those sizes? And I think in terms of like if we want to study the success of a movement, it will also be important to look at how the size of these protests are changing with time. And there is very interesting work in again statistical physics, complex systems literature on tipping points. Like when does a system start to undergo like a regime shift or a big transition? So you could think about that as a regime shift as overthrowing like an authoritarian, or you can also think about it as something like an ecological system undergoing a very big transition. From one type of state to another. And I think that there are tools. So I think complex systems and statistical physics are great places to pick up tools to be studying these problems. But it's not something that I'm doing very actively right now. So for example, like the protest, I'm not looking at protest data as of now. Yeah, I think that is my answer to your question.
Yeah. So in fact, thank you for helping us understand a political process using tools that we typically don't use. Right? I mean, generally, when you look at public policy, the analysis is from the lens of economics or other associated disciplines, right? It's quite fascinating to know that how from one discipline you can bring in insights and use it to understand political processes. Thanks for the deep dive, Aanjaneya.
Thank you so much. And and I do think that, when we were doing this work, we had to engage with a lot of political science literature, which I think is very important. Coming from a different background, it is important to learn about the ways people in that discipline have been thinking about. But I also really think that perspectives on a problem from various different disciplines are very valuable. And especially, problems which are of like great interest to society. I really enjoy the interdisciplinary nature of the study of complex systems, and I hope like the viewers got like a slight taste of what it could be like.
Thanks, Aanjaneya. Thanks to our listeners for joining in. We'll meet again in one more episode of All Things Policy.
Thank you so much.
If you liked our show, dive into Takshashila's research on technology, strategy, and economic affairs. Check us out at our Twitter handle @TakshashilaINST. or our website takshashila.org.in.